So welcome to the Alkane naming worksheet. Let's go over these individual structures and name them using the IUPAC naming system for all organic compounds. Again, this naming system basically is a convention that all scientists internationally have agreed upon because there's so many of these organic molecules that you could not ever try to give them a single common name to memorize them because structure is king. The naming system is based on its structure. And if you change the structure, you change its chemical properties. Okay, so the naming is based upon its structure. We need a new name for each structure because each structure has a unique set of what? Properties. Because of that structure, it's not about its molecular formula, it's about its structural formula in organic chemistry. So let's be crazy and go in order, starting with A. Okay, so here we go with letter A. Now, some people have trouble with this because they don't know how to look at this if it's written this way, but the first step in naming is find the longest continuous chain of carbons. That's going to be your parent name. So if I count, I can see that this is the longest continuous chain, and that's really all there is. There's nothing attaching to it. So I count 1, 2, 3, 4, and 5. And so I'm not going to have anything in front of the parent name, just the parent name, which is the ending. So what do I know here? Well, I do know that 5 carbons in a continuous chain is going to be a pent. Okay? And the next question is, hey, are these single or these double bonds? So the way to think about this is CH3. That's a C with 3 H's. I'm not going to fill in the H's. These are dashes. Each they equal the H. If we were in Regents chemistry and you read a Lewis structure or a structural formula, I should say, um, a dash off a carbon represents a hydrogen. We'll follow that. Okay, so CH2, well, okay, well, if this C is bonded to another C, now you may say, Mr. Grotsky, it's bonded to 2 H's here. No, they throw it here, but a CH2 means that this carbon here has 2 hydrogens bonded to that carbon. This carbon has 2 H's because if you notice, it's in the middle. And what I'm trying to do here is follow the idea or the concept that carbon must have 4 bonds because it has 4 valence electrons. And the ending carbon has CH3. So the only way to explain, all right, and again, if you're not following me, here's the CH3 ending. Here is the CH3 ending. Notice this CH3 ending. This is a CH3 ending. And then the middle carbons have CH2s because, well, because this middle carbon's bonding to 2 other carbons, it only has room for 2 more bonds or 2 more hydrogens. The ending ones have 3 because they're not bonding to another carbon, so they have room for 3 hydrogens. So what we understood here by doing that this is a saturated hydrocarbon, okay? And because it's saturated, meaning it's holding on to the max amount of hydrogens, or it's saturated because there's only single bonds here, we know that this is pentane. Very simple, okay? And there's nothing to put in front because there's nothing attached to the pentane chain. All right, so on to letter B. So in letter B, we're going to find the longest continuous chain. Now, people think it matters, but it really doesn't. Okay, and I'm going to explain why. The longest continuous chain of carbons is right here. All right. Now, I can undo this and do another longest continuous chain. I have several options here. In this case, I have 2 options. Okay, and that could be the longest continuous chain, and it's not going to matter. Okay, it's going to give us the same structure with the same set of properties. So let's just start with the first way I did it. So the longest continuous chain, remember, it has to be a continuous chain. I can't go 1, 2, 3, 4, and then pick this up. This is not part of the chain. So what did I just find here? I found an attaching group that's not on the longest continuous chain. Let's start with the parent name, the longest continuous chain. All right, and so let's count our carbons. This is going to be 1, 2, 3, and 4. That's the number of carbons in my longest continuous chain. and that is 4. And in table P, that is a but or a but I'll go with a but. Now, the question is, what kind of ending do I have here? Okay, is this single bonded, double bonded, triple bonded? Well, if I think back to the structure I did for A, CH3 is in the what? Ending here. That makes sense. If it's a single bonded to a carbon, you have room for 3 H's. Okay, notice this ending is CH3. Okay, for the same reasoning. And then you have the CH2 group, okay, that's in the interior. Now you would think that this should be a CH2 also if it's an alkane. But why is it CH? Well, it's CH because this carbon is bonded to another carbon, and it's bonded to another carbon. In fact, it's bonded to 3 carbons. I know this line is going in between. So because this carbon here is bonded to 3 carbons, it only has room for 1 H. So this is telling me that these are single bonds, and this would be a butane. Now, if you're not following me, okay, we can draw this structure. And I'll draw it right here. Okay, so we'll do CH3. That means this ending one. That's this one right here. We're going to do a C and H. Now, this only has room for 1 H because it's bonded to another C. And this one has 2 H's, and I don't need the H's, so I can get rid of that. Just the dashes we'll use. So this is CH2, and the ending here is CH3. That's the 4th carbon in my continuous chain is CH3. And then you notice this is going to bond to a C, who's bonded to 3 other H's. And now why? Because that carbon is terminal. Terminal carbons, if they're single bonded to only 1 carbon, have room for 3 H's. So that there's your structure. So based upon the hints of giving me the H's, I can see that there's single bonds between the carbons, and that's how I knew it was a butane. Okay, however, there's an attaching group here. All right, and I'll make this, so the attaching group is a 1 carbon group. And as we learned from table P, that's a meth. So I'll put meth. Now what we do to call them an attaching group, we add YL. So this is methyl. So we have a methyl group attached to the parent name. Okay, it's not good enough to say methyl butane because remember, the naming system is based upon the structure, and the structure has to be succinct. We have to know the structure. So the question is, where is this methyl group? Well, we're going to put it on, or it's on the 2nd carbon. So we say 2-methyl butane. We have a methyl group attached to a 4-carbon longest continuous chain that has single bonds. See, the naming system is describing the structure, and that's what this is about. We call this a substituent, something attaching group. So there's where I know where it is. Now, remember, when we number the longest continuous chain, we number it in a way so that the attaching group, the substituents, have the lowest number possible. And you may say, well, why do we do that? We do that because that's part of the convention of the IUPAC naming system. They decided that if you're going to name an attaching group, we should make the decision to put it on the smallest number. Could they have decided to make it on the largest number? Yes, but they didn't, so we have to follow that convention. So if you have choices, you always put the what? The attaching group on the lowest name. If you were to put 3-methylbutane, this would be wrong. Okay? All right, on to letter C. All right, longest continuous chain. All right, I could do this. All right, this would be 1, 2, 3, 4. I can go across 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. All right, now if I keep it this way, people I say, why do you do it that way? Because I notice that either on the 1, 2, 3, the 3rd carbon, or the 1, 2, 2nd carbon, guess what? I have 2 attaching groups. Okay? And each one of these are methyl groups, right? So there's 2 of them on the 2nd carbon. Now, if I get rid of this, okay, and people say, well, why does it, okay, why am I allowed to do this? Why can I number them, okay, just going straight across? Don't worry, you can also, if it's the longest continuous chain. Notice on the way that I previously drew it, sorry, the two methyl groups, so two attaching groups that are not part of the longest continuous chain, were on the second carbon. Now notice this one, 1, 2. The way that I drew it here, both these methyl groups are on the second carbon, so it doesn't matter. And you say, well, why does that work? Well, if you remember my lecture, okay, or the time that I did this in class, is that when you got single bonds, okay, you can rotate this thing on single bonds. So these things are free to rotate. And because they're free to rotate over these single bonds, not double or triple, you can have multiple, not arrangements, okay, but multiple conformations, okay, that are essentially the same. So we're going to leave it this way to work on it. But if I numbered it or did it the same way that I did before, it'd be exactly the same thing. So let's number, okay, so that these attaching groups, and what are they? Okay, well, there are a 1 carbon group here and a 1 carbon group here. They're separate. They're not 2 carbon groups. They're not 1 2 carbon group. They're 2 individual groups that have 1 carbon. That's really important. So let's number these carbons. 1, 2, 3, 4. I'm numbering the parent chain, so I know it's a butte. Table P. I can understand by the structure, if you follow me through A, B, and C, that this is a butane. You say, how do I know it's a butane? Well, what do I have? I have a terminal group that's CH3. That means this carbon's bonding to 3 H's. Carbon bond makes 4 bonds, so it only has room to bond to 1 carbon. This carbon in the middle of this carbon is bonded to this carbon and that carbon, so it only has room for 2 H's. This carbon doesn't have any H's because it's bonded to this carbon, and it's bonded to this carbon above in this methyl group, and this carbon below in that methyl group. So it has no more room, since carbon can only bond to 4 things to make its octet. And this is a terminal one. So if you need to draw that, but this is clearly a butane based upon the what? The hints given to me in the hydrogens. And if you have to draw it out like I have been doing, be my host or my guest. All right. Any case, let's continue on. So party people, we have a butane, but what do we have? We have 2 attaching groups. They're 2 different ones, and each are a individual. So what we have is a methyl, okay? And so we have, we have a methyl. It's a 1 carbon group, meth. Because it's attaching group, we add a YL. Now, some people would say, okay, that those methyl groups are on the second methyl, and they'd put a 2 here. And that'd be wrong. If you say 2-methylbutane, it'd be the same thing as what I just drew here. But I have an extra one. So I need to say there's 2 of them there. So guess what I'm going to need? I say we put a prefix here, dimethyl. All I'm putting in is a di. Di means 2, like a dicycle. You ride a dicycle maybe? Okay, but di means 2, so dimethyl. Okay, and a single number wouldn't cut it either. If you say 2-dimethylbutane, you're saying that one of the 2 methyls is on the 2, but you don't give me the other number. Couldn't this methyl be on this carbon also? Sure. So you've got to tell me a number for each attaching group. So this must be 2-2-dimethylbutane. And then one way to check to make sure you got this right, could you use this name to draw it? Sure. Bute, 4-carbon chain. Ane, single bonds between the carbons. Hey, dimethyl, there's 2 methyl groups. Where are they? Each one is on the second carbon. Okay, moving on to letter D. Okay, letter D here. First step, find the longest continuous chain. Don't get all confuddled because this thing is not going straight across. Remember, single bonded hydrocarbons can rotate on their single bonds and make these different conformational differences, but are the same shape, okay? So the biggest mistake people do here is say, oh, I'm a robot. We always go across to find the longest continuous chain, and that would be wrong. This would be 1, 2, 3, and you'd have a 2-carbon group. So a lot of people I've seen say, oh, this must be a 2-ethyl propane. Wrong. Wrong. And the reason why that's wrong is because the propane is not the longest continuous chain. The longest continuous chain is 4. Just because it goes up doesn't mean it's not a longest continuous chain. Remember, guys, these guys aren't really planar and going in a row. Remember, carbon makes a tetrahedral shape, right? So it's going to tend to, remember, this one's coming at you, this is behind you. So these things are going to make, okay, different structure. This thing's going to go up and have a continuous tetrahedral for every one of these carbons. So it's not going to be straight across. All right. So it's important you realize that to begin with. And they can rotate. So I have my longest continuous chain. Next, I'm going to number my carbons, or by finding the longest continuous chain, what am I identifying? Well, I'm identifying the substituent group. Okay, in this case, who is the attaching group? Oh, that's not part of longest continuous chain. I've got a 1 carbon group, and there is my methyl group. Okay, so let's go name this. This is a 4 carbon group, so it's a bute. And I know it's an ane because of the hints. CH3 is terminal. CH3 is terminal. In the middle is CH2. This carbon is bonded to this carbon. It's bonded to this carbon, and it's bonded to this carbon. So it only has room for 1 more H. I know the line is going up, but it's really this carbon is bonded to this carbon. Okay, and so this carbon only has room for one more bond, and so that makes sense. It'd be single bonded. And again, if you're not sure, draw it out. Here's a carbon. That's my terminal. Here's a C. If it's single bonded to a carbon, this one is going to be bonded to this carbon here. And then this is going to be bonded to the CH3 right here. Okay, that really could help you. All right, so it makes sense that this can only bond to a single H here. And of course, this is bonded to another carbon who's got a CH3. And because this carbon is bonded to 2, it only has room for what? 2 H's. So it all makes sense if you draw it out. So this carbon here makes sense. It can only be a CH, because if carbon is going to only make 4 bonds, it only has room for 1 more H. All right, so again, that is very helpful to draw that out. Okay, so let's name this. Well, we have this CH3 group. Okay, so it's a methyl, and we write it as such. What is attached in the parent chain? We find the longest continuous chain. We identify the bonds between the carbons. We add YL. Remember, bute and meth are found in your table P of your reference table. Ane is also found in table Q to say it's single bond, but you may have to draw it out if you don't see this yet. You will, okay? And now, where is this methyl group? If I said to you, hey, I have a methyl butane, you wouldn't know where to put the methyl. So we've got to number the carbons so that the attaching group has the lowest, what? Number. So 1, this is a 2, this is a 3, and this is a 4. So on the second carbon, all right, I've got a methyl group. So 2-methylbutane. And you could put these words together and it's fine, okay? The bottom line is that it goes on the second carbon. Don't number this 1, 2, 3. If you said 3-methylbutane, wrong. The convention is what? That we have the addition or the substituent group, all right, the additional group on the lowest number carbon. And if you noticed, okay, above, we also have 2-methylbutane above. So these two structures are essentially the same. They have the same set of properties, okay? Even though we drew them a little bit differently, okay? So cool beans if you like beans chilled. Okay, so on to letter E. Again, longest continuous chain. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Doesn't really matter. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The longest continuous chain is 6. Couple different ways to do it. Okay, I'm going to do it this way to be a little bit different possibly than the way you did it, but it's going to be the same thing. So where's my substituent groups? I have a 2-carbon adding group here and a 2-carbon group added here. Let me number these carbons. I can go 1, 2, 3, 4. On the 3rd carbon, I have this group. 4th group, I have this group. I can go 1, 2, 3, 4. It's not going to matter. 1, 2, this is the 3rd carbon, 4th carbon, 5th carbon, and 6th carbon. Okay, so I got 6 carbons in my longest continuous chain. It doesn't have to be straight across, party people. So if I look at table P, that's a hex. And if I look at the H's, terminal CH3, middle CH2, this carbon is a CH because it's bonded to this carbon, bonded to that carbon, and this carbon only has room for one H. Okay, and you could see that I have an error here because this should be CH. No way that works. So if you pick that up, I feel bad. That's a CH there. Because if this carbon's bonded to this carbon and it's bonded to this carbon, okay, it only has room for one H if it's bonded to three carbons. Now this is bonded to a carbon, this is bonded, so this two, all right, should have been drawn right here. So the little issue with this structure doesn't make sense. All right, so CH3, CH2, okay, so that should be a CH2 there. Okay, so if you saw that, I feel bad, and now I'm over it. Okay, so single bonds between the carbons based upon, again, how the correct number of H's should be. Now, all right, so I've got these two carbon groups, okay? Oh, this is a two carbon group, so it's an F. And because it's an attaching group, we add YL. Why? Because that's the convention. They came together, a group of scientists in a meeting, and said that's the way we're going to do it. But I have two ethyl groups, okay? So this is going to be, yes, you guessed it, diethyl. And where are they attached to? Well, this ethyl group's attached to the fourth carbon. This ethyl's attached to the third carbon. So we just go 3, 4 diethyl hexane. You have a hexane longest continuous chain, and on the third and fourth carbon, you have an ethyl group, and you have two ethyl groups total for diethyl, and that's it. So there's a little problem with that structure. I feel bad, but now I'm over it. On to F. All right, so if I look at F, this should be a pretty easy one. Longest continuous chain is 2, 1, 2. Notice the two terminal carbons, so this has to be single bonded between the carbons, right? If this carbon is bonded to this carbon, hey, guess what? They both have the ability to bond to 3 other H's. Draw it out if you don't see it. 1, 2, 3, 1, 2, 3. If this is a single bond, well, because there is 2 carbons, we do eth. Now it's not an ethyl because they're not attaching. That's part of the chain, and we have determined by the hints of the hydrogens that are in the structure CH3, CH3 that this must be an ethane. And there's nothing attaching, so that's just ethane. Okay, so on to letter G. Okay, and let's go find the longest continuous chain, and I'll try to clear this. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So I'm going to just keep it straight across. It doesn't have to be. These things, if they're single bonded, can spin on themselves. Now, I'm going to number my carbons so that these attaching groups, and what are the attaching groups? The attaching groups are the groups that are not part of the longest continuous chain, okay? So I've got 2 different groups, and if I were to number these, okay, 1, 2, 3, this would be the 4th carbon, 5th carbon, and 6th carbon. So I've got a 2, 4. Okay, now if I was to number in the reverse, 1, 2, 3, 4, 5, and 6, the attaching groups would be 3, 5. So my question to you is, what's a lower number combination? 3, 5 or 2, 4? Okay, well, 2, 4 is the way that we want to do it because 2, 4 is a lower number combination. Careful, the IUPAC naming system by convention wants to name these guys based upon their lowest number combination. So we figured out that we have 2 different groups on the second and fourth. Let's start with the parent chain. Okay, it's 6, so based on table, P, it's a hex. Based upon CH3, CH2, CH, because it's bonded to an extra C, CH2, CH bonded to an extra C, and then a CH3, this must be an ane. Again, if you don't see that, draw it out, and it'll show that there's single bonds between the carbons. That's where the ane comes from. Now, what do we got attached here? Well, party people, we've got ourselves a 1 carbon group. That's a meth. We add the YL by convention. That's a methyl group. Here we have a 2 carbon group. That's an F. And by convention, we add ethyl. Okay, so we've got an ethyl and a methyl. So we're going to describe by alphabetical order the ethyl first. Okay, so where is that ethyl? On the fourth carbon. So we're going to say 4 ethyl, and then on the second carbon, 2 methyl. Hexane, and it describes the structure. We have a hexane longest continuous chain bonded. We have 6 carbons bonded to each other in single bonds. And on the second carbon, we have a methyl group. On the fourth carbon, we have an ethyl group. You could draw that, and we're going to be doing that very shortly by a tall teacher coming up. So 4 ethyl methyl. Now, if you said 2 methyl ethyl, like, we'd accept it, but generally speaking, they put the E alphabetically before the M. All right? Okay, so here comes our other structures here. Now, these guys are showing what we say the carbon backbone. In organic chemistry, okay, when typically they don't draw out all of these CHs. They'll just draw lines, especially when they become cyclic compounds. And the corners of the cyclic compounds are the carbons, okay? And they sometimes eliminate the H's. They just show, hey, there's a single bond. We know, you know that there's going to be, what, 2 more H's here. So that's what they do. Okay, so you can just think that there's H's here and that these lines here are single bonds. Now the question, and of course the corners are carbons. So the question is, what do we name this? Well, the backbone is going to be the cyclic compound. So we count the longest continuous chain that's part of the cyclic compound. So what's part of the cyclic compound, which is basically the tail bonding to the head, is 1, 2, 3, 4, 5. So always the cyclic compound is, in this case, the longest continuous chain. So this is 5. Okay, so this becomes pent. And we can see in the cyclic structure that there are single bonds. These lines represent bonds. If this was a double bond, it'd be a double line. It's not, so we'll get that out of there. So it's screaming to you that this is a pentane. Now, because it's cyclic, we have to put the cyclo for cyclic in front. So this is cyclopentane. And because we have something attaching to the longest continuous chain, which is really cyclic compound in this case, hey, we've got ourselves a methyl group. And so we put the methyl saying, hey, there's a methyl group. Now, in cyclic compounds, they typically don't start with a number. So this would be methyl cyclopentane. And it could be anywhere in this group attached. You may say 1 methyl cyclo, but if there's only 1 methyl, we don't need a number. It's when you need a second number, and then we're starting to get into a whole different type of nomenclature. I'm just giving the introduction here. When you have multiple attaching groups on a cyclic compound, then we start adding the numbers. And again, the rules get a lot more complex. We're just scratching the surface of these types of naming systems, but I just want to introduce that to you. So this is methyl cyclopentane. All right, on to I. Okay, so what's I? All right. Okay, well, I is a rectangle, silly. If you don't know your shapes, you should go back to elementary school. No. Okay, I know, I was being tough there. This is a cyclic compound showing the backbone. The corners are the carbons. Okay, so the longest continuous chain is the cyclic compound. So we've got ourselves a bute. And we know they do not show the hydrogens, but I know it's a butane because these are single bonds. They would show a double or triple bond in this cyclic compound. But because it's cyclo, we just put a cyclic compound, we put a cyclo in front. C-Y, oh my gosh, I got cyclo. I guess I forgot the C there. Okay, so people are screaming at me, so let's go back to H. Okay, that was a cyclo. Woo! And I couldn't hear you when you said, you spelled it wrong. Yeah, I know. Cyclo. All right, I can do this. And I almost spelled it again. So cyclo. Okay, so cyclobutane. Okay, and that's all that is. Yes, it's a rectangle, but it's also cyclobutane. Obviously, okay, they didn't show you the H's, and they don't. And you'll see those structures all the time. Another example that you probably saw, definitely for me or your teacher, is that there's something called a benzene ring. And it's important to realize, even in organic chemistry or in reagents chemistry, that these carbons make cyclic compounds. Remember, these are carbons here. And in benzene, and let's get rid of them for a second, undo. Okay, in a benzene ring, we have these alternating double and single bonds. Now, if these guys are corners and each corner is bonded to 3 bonds, it only has room for one more H. Now, don't draw the H, but we know that these are C's bonding to one H. Remember, this carbon is bonded to 3 bonds. Every carbon in every corner is bonded to 3 bonds, so it only has room for one more H. And that's why benzene is C6. Remember, there's 6 corners, H6. And it has that resonance. So a lot of times, because of that resonance, they'll draw a benzene with this ring to show the delocalization of electrons. Okay, on to J. All right, now in J, which is very, really important, what we're going to do in J is draw the structure based upon the name. That's the power in this naming system. This naming system is about the structure. Structure is king. So I'm going to start always with the parent name, pentane. And I'm going to put 5 carbons. 1, 2, and I didn't plan this out, 3, 4, and 5. Now I knew they were single bonded, so I had 5 carbons for the pent. Ane is single bonded between the carbons, and I have a dimethyl. I have 2 methyl groups. Methyl groups are CH3s, and it's telling me they're both on the same carbon. So I'm going to number this 1, 2, 3, 4, and 5. I could have numbered the other way. It's not going to matter here. Bottom line is, I know that I have a CH3 on the second carbon, and I have another CH3 on the second carbon. That means this doesn't have any H's. And then I fill in the rest with H's. This would be a CH3 ending. This would not have any H's. This has room for 2. This has room for 2. And this, being terminal, has room for 3. You don't have to put the H's in. Dashes work. And notice, what if I put these 2 methyl groups on this carbon? That'd be totally fine, because what if you take it up and flip it over? It'd be the same exact thing. I know it's hard to see that, but if you were to flip it over, if this was a flat, it's not really flat, it's a tetrahedral on every carbon, but it works fine if you flip it over, so it would work out fine if you did it on that side as well. And there you go. I'm using the name to write the structure, because the structure is the name. Okay, so on to K. All right, so the first thing I do is look at the longest continuous chain. I have a 5 carbon chain that's single bonded. So I'm going to start that way. 1, 2, 3, 4, and 5. Okay, now what do I have? Ooh, trimethyl. I have 3 single bonded carbon groups. And of course, where are they? Okay, well, I'm going to go 1, 2, 3. I'm going to go left to right. So I have a methyl group here on the second. This would be 1, 2, CH3. I've got a methyl group at the third, CH3. And I got a methyl group at the fourth, 1, 2, 3, fourth. Now, you notice I'm going up, down, up, down. It would not matter if you had all 3 on top, all 3 on the bottom. Remember, these things can actually rotate on their single bonds. All right. And if I left it like this, I'd get it wrong. I have to fill in the carbons with the hydrogens. Remember, this one only has 1 H. This has 1 H. This has 1 H. The terminal has 3 if they're single bonds. Okay. And that's my 2, 3, 4, 3 trimethyl pentane. Okay, again, very simple now, right? Again, it's very interesting. Now, it won't matter if I made this the second, third, and fourth, it'd be the same structure. Hopefully you can see that. On to L. Letter L. Ethyl cyclohexane. Got a cyclo compound. And I have what? 6 corners for the hex. So I'm going to draw it like this. Okay, I have 6 corners. Okay, so it's a hexagon. All right, and every corner is a hydrogen. But on one of the hydrogens, or one of the corners, I have an ethyl group. Now, what's an ethyl group? It's a 2-carbon group. So this bonds to a C, and this bonds to a C. Okay, careful here. You've got to make sure that, all right, we fill in the rest with H's. So if you didn't put it this way, it would come off how? We would have bonded this to a CH2, CH3, because this CH2 is in the middle. And that'd be the same thing. It won't matter where you put the ethyl group. If they're just one, okay, it can go anywhere and be the same structure. So there is ethyl. There's my 2-carbon group. YL tells me it's an attaching. Cyclo, that means that the tail is bonded to the head. Hex means I have 6 of these corners, and ane is their single bonds. All right, I'm going to name these silly rabbits. Let's go on to M. Okay, longest continuous chain of carbons. This is a Cl now. And so now we're going into a new area of naming. If you go to table R, they have names for these halogens. Br is bromo, F is fluoro, and Cl is chloro. So we're not using methyl, ethyl, or propyl. We're using this. So longest continuous chain is 1, 2, 3, 4. So I have a bute. And based upon that, how this works out. Now this chlorine is bonded to this carbon, okay? All right, and so what we have here, and again, if you're confused about whether it's single bonded, draw it. That's the key here. I have a CH3 terminal ending. I'm bonded to a C that has one H. It's bonded to that Cl, which is my substituent group that's not part of the longest continuous chain. Okay, then I've got a CH2. Well, that makes sense if it's single bonded, because if it's going to be bonded to another carbon, it can only have room for 2 H's. Now this is CH2 because it's bonded to a chlorine. So if you just draw it out, you can clearly see, party people, that this is a butane, single bonds between the carbons. Now where are these chlorines? Where are they? Now we could name this incorrectly 1, 2, 3, 4, and that'd be a 2,4, okay? Remember, there's 2 chlorines, so dichloro, but that's not correct. All right, so we go undo that sucker and undo that. So if I name it, I'm going to name it 1, 2, 3, or we have 2, 4. So I'm going to name this 1, 2, 3, 4 carbon. So this tells me that on the first and third carbon, 1, 3, I have 2 chlorine groups. So we go di, like we've been doing, like for dimethyl, dichloro. And I get the chloro from table R. Okay, the table R reminds me if I have halogens. Remember, halogens are group 17. Fluorine, chlorine, bromide, iodide. Remember, fluorine is fluoro, Cl is chloro, Br is bromo, and I is iodo. Okay, so those are the name of the attaching group. Nothing you have to memorize. We're still using the same convention. So that's table R there. So this is 1,3-dichlorobutane. I have 2 chlorine groups, one on the third, one on the first, and the parent chain, the longest continuous chain, is a 4 with single bonds, and there it is. Okay, going a little more quickly here. Okay, longest continuous chain. We're on to number N, the longest continuous chain. Okay, don't get befuddled here. Longest continuous chain of carbons is right there. Don't think because this is coming off this one, it's an attaching group. 1, 2, 3, 4. So we've got ourselves a bute. Okay, and this is going to be a butane, and I made another mistake here. Okay, this should be a CH2. All right, and boy, it looks like to me that I meant to put this line over here. Okay, so let's work on that. Okay, it looks to me the way that I had this kind of moved over. All right, so just make this interesting. Let's put this CH3 here, even if you didn't already. All right, and let's make that all white. It'll be all white. So let's do that. And now that makes sense the way that I drew that. Okay. All right. So that's the way that should be. All right. And if I told you to do that, okay, good stuff for me. All right. Now let's continue on. All right. Because this makes it a little more challenging. So now it's not a butane anymore. Okay. Longest continuous chain, okay, is going to be a prop, 3-carbon group. So this would be a prop. Now, based upon what we've learned, this is a propane. All right, CH2 because of the R. CH3 is bonded to this carbon. This is bonded to this carbon, and this carbon so only has room for one H. That's terminal CH3. That makes sense. So it's a propane. Okay, again, if you don't see it, draw it out, and you'll see that. Now, what do I have? Well, let's number these. This bromide is on the first, okay, carbon, and this CH3 group. Remember, these are my attaching groups. Once I find my longest continuous chain, I have a bromo group. Oops. Now the bromo group is from table R. If you forget that in table R, we have those halocarbons, and this is showing you that if you have bromine, okay, this would be a bromo group. And of this, of course, that's what this is here. And if you have a chlorine, it's a chloro. If it's an F, it's a fluoro. And if it's an iodine, it's an iodo. Okay, this is going to be a methyl group. All right. And so what do I have? Now, how do I number these? Well, I could number them 1, 2, 3. That means my attaching group's on a 2 and 3. But if I number correctly this way, 1, 2, 3, keeping the convention that the attaching groups must have the lowest number, this is going to be, hey, on the first carbon, there's a bromo group. On the second group, there's a what? Methyl group. So we're going to say 1 bromo. Hey, I got a bromide on the first carbon. And then 2 methyl. And the reason I went 1 bromo is because B goes before M on in alphabetical order. But if you had 2 methyl, 1 bromo, I'd accept that. All right. So that's how that works. Longest continuous chain. Okay. Let's go to a letter O. And we've got ourselves, and this is easy. It's showing us a single bond. So that's a propane. And we have, what's our attaching groups? Ooh, we have 2 bromos and a chlorine, a chloro. And how do we number this? Well, I'm going to number it 1 carbon, 2 carbon, 3 carbon. That's going to give me my attaching groups on the lowest number. If I number the other way, it's going to be a 2, 3. This is a 1, 2. 1, 2 numbers for my attaching groups of the bromide and chlorines, okay, is a lower number combination. So on the first carbon, I have 2 bromides. Okay, so I'm going to say 1-1 dibromo, and I'm going to need more space for sure. And why do I put dibromo? Because there's 2 bromos. And why do I put 2 numbers? I put 2 numbers to say that where each of the bromides are. Okay, so because there's 2 on the same carbon, I need to tell you that. If you were trying to draw this and I said 1 dibromo, where'd the other one go? I'm telling you, they're both on the same carbon. So 1, 1, a number. You need a number for every attaching group. Okay, and then of course I have 2 chloro. And then the parent name is a prop for the longest continuous chain of carbons, and they're single bonded. Okay, and so that would be propane. So 1,1 dibromo 2 chloropropane. A lot of words there, but that describes the shape. We have a 3-carbon single bonded hydrocarbon with a chloro group on the second and 2 bromo groups on the first. All right, continuing on to the next page. Letter P. Okay, a little more complicated structure here, but again, first thing is longest continuous chain. So I'm just going to start counting to see what that might be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if I start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it seems to me 10 is a longest continuous chain. So I'm just going to circle what my chain is, my longest continuous chain. I know I could start here or here, but I'm just going to circle this. And there certainly could be another correct way, which would lead us to the same results. So there's my longest continuous chain. Again, I could have started here, and then this would be a 2-carbon group if I start this way, okay? And if I ended up this way, okay, if this was my longest chain, and this would be my methyl group in this case. So my attaching groups are here. These are not part of the longest continuous chain, and these are going to help me number my carbons so that these attaching groups have the lowest number possible. So if I number this way, 1, 2, this would be a 3, 4, 5, 6, 7, 8, 9. So I'm going to have a 3, right? If this is 3, 4, 5, I'm going to have 6 and a 6, and then I'm going to have a 9. That's one possibility. Now, if I number the other way, this would be a 2 methyl, right? 3, 4, 5, 2, 5, 5. And you already see that's a lower combination. And this would be an 8. So all I did was number the opposite way. And I can see that if I number this 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, that's going to give me a 2-carbon, a 5, 5, and then an 8. If I number the other way, it'd give me a 3, 6, 6, 9. And remember, the numbering is based upon, or the IUPAC naming system is based upon, by convention, the lowest numbered possible structure for your adding groups. Okay, so now that I have identified my longest continuous chain, and now that I have numbered correctly, I'm ready to name this. Okay, longest continuous chain was a 10. And if I go to table P, that's a dec. And if I evaluate this, CH3 ending, CH2, CH should be CH2, but because it's bonded to 2 carbons, it only has one position, CH2, CH2. This is a C because it's bonded to 4 carbons. I can see this is a CH because it's bonded to 3 carbons. CH3, this is a single bonded, so this is definitely a decane. This is an alkane. I know it's called the Alkane naming worksheet, but I did throw in some, if you notice, some unsaturated compounds in here. Okay. Now, what do I have here? Well, I have 3 1-carbon groups. And as we talked about, a 1-carbon group is a meth. And when it's an attaching group, we add a YL. So I've got a methyl. And then I have a 2-carbon group. That's an F, right? Table P. And then you add the YL if it's an attaching group. All right. So we're going to have 3 methyls. So it's a trimethyl. Okay. And I know that Fe comes through 4M, so I'm going to start with my ethyls. Okay, and so I'm going to go 8 ethyl, right? And then I'm going to go 5, 5. And I probably should, I should put the numbers in order. I mean, if you don't, it's okay, but people do get crazy. I'm going to go 2, 5, 5, just to put the numbers in order. 2, and of course 5, 5. And I need a number for every attaching group. Now there's a methyl group. Okay, and because there's 3 of them, I need to put trimethyl. And there it is in all of its glory. The attaching groups and the correct carbons with the parent chain with the single bonds. And what looked very complicated, okay, we have this name. So 8-ethyl, 2,5,5 trimethyl decane. Now, again, I could have made this the longest part of the chain and it wouldn't have changed it. This would be my ethyl group and so forth. All right. All right. So cool beans. All right. Now let's go on to Q. All right. Longest continuous chain. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So my longest continuous chain is 7. So I'm going to draw it right here. Again, I could draw that one more way here, but it's not going to matter. All right, now I notice I have 1, 2, 3, 4, 5, 6, 7. So I have 7 in my longest continuous chain, my parent name. So this becomes a hept. Now I also notice that I've got a double bond here. And so no more is this ane from table Q. If you've got a double bond, that's an ene. Okay, so I've just found my ene. Now the question is, where is that double bond? It's on the first carbon. So I got to count. 1, 2, 3, 4. We name the carbon that starts it, or 1, 2, 3. So when I name something with a double bond, the double bond takes precedence in the numbers. And I'll explain that in a second. So this is 1, 2, 3, 4, 5, 6, 7. That, of course, is where I get my hep from. The ene is right here. And so when I count this way, this gives me a 3 heptene. This number is telling me the ene, the double bond, is on the starts at the third carbon. I could have counted reverse. 1, 2, 3, 4. That'd be 4 heptene. Remember, the convention is the lowest number. All right, so the double bond takes precedence. So I have to number this way because people would say, well, that's going to be 5 methyl. Wouldn't it be better to make that 1, 2, 3 methyl? And that would change the double bond. Since the double bond takes precedence in the numbering, I am now locked to give this heptene a 3 to make sure that the lowest number possible for the ene is more important than the substituent group. That's what it means, takes precedence. And there's a whole bunch of layered rules here as this gets more complicated. We are way beyond the Regents curriculum, but I'm showing how this works, okay? And so it's more fun this way. Any case, so this would be a 5 methyl 3 heptene, okay? Yes, some people could say, well, 3 methyl, okay, 4 heptene, but we have to make sure that the lowest number is for the ene first, okay? So 5 methyl 3 heptene. All right, so on to other structural formulas to name. That this way they don't give you the ball and stick, so you have to be careful and look at the hints given to you by the hydrogens. Okay, longest continuous chain, well, that's easy. It's a long chain hydrocarbon. So 1, 2, 3, 4, 5. So we have a pent. Now, hold your ponies or corral your ponies for a second. You might say, well, it's a pentane and move on, but careful, careful, careful. CH3 makes sense. And if you don't see it, draw it. Here's a carbon with 3 H's because it has a single bond. The only way this could be CH3 at the end is this is single bonded to a C. Now this C only has 1 H. There's my dash. And it's bonded to another C that has only 1 H. Then we go to a C that has a CH2. That's ones we've seen before. And then the CH3. The only way to explain that these guys don't have another H is that there must be a double bond between the second and third carbon. 1, 2, 3, 4, and 5 carbon. It starts the second. Now, I could name this 3 or 2. 2 is the lowest. So this becomes 2 pentene. So you needed to understand that normally if it was an alkane, that'd be CH3, CH2, CH2, okay, for these carbons. But because they had one less H, because they're what? Unsaturated, and they're unsaturated because they hold less H's because there's more bonds between the carbons, okay? So that's 2 pentene. We go to S, longest continuous chain, that's easy. 1, 2, 3, 4, so it's a bute. And don't say butane, because we've got to evaluate the C's here. CH3, that's easy. That means this carbon must have a single bond. Now this carbon has no H's. It's bonded to another carbon with no H's, and then the other ending carbon terminal, oops, I don't need the H's there. The dashes work fine. I'm done there. Well, how in the world can carbon only make 2 bonds? It can't. It must make 4. The only way to explain this is there's a triple bond. So this carbon has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. And that's got a triple bond, and that makes it an ine. And what carbon is that triple bond on? Well, no matter how you count, in this case, it's on the second carbon. So we'd say 2-butyne. All right. So here's make sure you evaluate your hydrogens. Your hydrogens on the carbons are the hints of what kind of bonds exist and where, and we name them, of course, with the lowest number possible. All right. Moving on to a T, we're going to draw the following structures. Okay. And so again, that's the power in this naming system is once you have the name, you have the structure. You have the structure, you have the name. So I'm going to start with pent. And I'm going to do 5 carbons. 1, 2, 3, 4, and 5. And on the second carbon, I'm going to count this way. If you count this way, that's fine too. But on the second carbon, I've got an ene group, which means a double bond. All right. The rest have single. All right. So just because I've decided that I'm counting this way, this is carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. Okay. Now, there's this 3,4-dimethyl. All right. Well, on the third carbon, I've got a methyl group. I'm going to draw CH3. It's terminal with a single bond. There's my methyl group on the third carbon. And I can do that, but I can't add any H's here because carbon has 1, 2, 3, 4. That's it. There was only one spot open, and the methyl group takes it. And on the fourth one, I've got another CH3 group. It's a dimethyl, 2 methyl groups, and here are the 2 number carbons. The double bond takes precedence. So once I identified my double bond, it had to be that. I can't make this 2, 3, okay, 3-pentene. Okay, it has to be that the double bond takes precedence. All right, so that's how that looks. And of course, I fill in the rest with H's. And notice this says 1, 2, 3. I need an H here. If you forget this dash here, you're wrong. If you put a dash here, you're wrong. It already has 4. This says 1, 2, 3, 4. 1, 2, 3. And there's your structure. Don't have to draw in the H's. Okay. All right. This is letter U. I'm going to start with, okay, hex. And that's a hexine. And it's on the third carbon it starts. So here comes my 6 C's. 4, 5, and 6. I'm going to count this way. I don't know why I'm counting backwards, but I'm just going to choose. You could definitely go, let's go probably count in the forwards because people won't let me do that. So I'll make this 1, 2, 3, 4, 5, and 6. The triple bond takes precedence. That's going to be on the starting on the what? Third carbon. 1, 2, and 3. All right. Now, the first carbon, if this is the third carbon for triple bond, that takes precedence. This is now the first carbon, and I have a trichloral. Chloral is table R, and that's a Cl. And I have 3 of them, all on the what? Same number 1 carbon, so that becomes chlorine, chlorine, chlorine. Okay, nothing else. Make sure I put bonds between the carbons. Everything else is a single bond. And make sure every carbon has 4 bonds. So this would be an H. This would be an H. Nothing is added here because it has 4 bonds. Nothing is added here. It has 4 bonds. But this has 2 bonds, the 5th carbon. So I need 2 dashes for 2 more H's. And this terminal carbon with 1 bond is a CH3 ending. And that's it. Okay. So cool beans. Again, if you need to draw a hobbit, I think they're small. Okay. So I think they have big heads too. So they're, not sure why. And of course, if you draw yourself, okay, I'm going to draw me. Okay, I guess got a long neck. And of course, the biggest attribute or property or allele I have is that I smile. Okay, all right. So hope that helped, and that should be a great review of naming these types of compounds up to table R and the halocarbons. All right, hope that helped.